Hey everyone, today we're going to be talking about creating stuff like this for your residential Revit projects. That's right, we're going to be talking about structural framing, headers, foundations, you name it, we're going to be working through it. And yeah, I'm so excited to jump into it. It's been a little while. So with that, let's roll it. All right, hey everyone, welcome to episode 118 of BIM After Dark Live. Thank you for joining. If you're here live, thank you for tuning in live on this Tuesday night or Wednesday morning, depending on where you are in the world. My name is Jeff, also known as the Revit Kid. If you're not familiar with the show, it is a weekly live stream in which I talk about Revit, BIM, and any really associated technologies to the advancement of digital models and construction. So today what we're going to be talking about is a continuation on a project called the North Wing. And for those of you who haven't been following along, make sure you check out the previous 117 episodes. Also, make sure you subscribe to the channel here on YouTube and hit the notifications, because as much as I try to keep this a regular live stream, sometimes I may have to modify what nights we go live. I haven't been live in almost 2 months, so thank you for coming back. I see a bunch of returning folks here in the chat. I've been doing a lot of stuff outside of the live stream. Hosted a conference here in Connecticut called Niche BIM. If you didn't see that, head on over to nichebim.com and sign up for information on next year's. But it was an awesome in-person conference here in Connecticut. And then I also was traveling to AU 2024, Autodesk University, last week, 2 weeks ago, however long ago it was now, in San Diego, and spoke at 2 sessions there, and so on and so forth. So I was focused a lot on those events. And so last time we left off at episode 117, I was introducing you to a home edition that I am designing and building. And this season of BIM After Dark Live, we are going to be walking through the process. So we talked a little bit about the design process before. And even some twin motion and some presentation stuff. And now we're moving into the meat and potatoes, in which we're going to be doing documentation. We're going to be doing modeling of structures, MEP, mechanical, electrical, and plumbing, separate models there. Some documentation tips and tricks, and some of the GC side of it, some of the contractor side of it that I'm hoping to share with you guys. So I'm super excited about that. If you're here live, definitely keep an eye on the chat. Ask questions as you go along. I will do my best to see them as I'm going through the content and respond. That's one of the cool things about being live. With all of that being said, I think it's time to jump in. The first thing that we're going to do is I'm just going to give you a quick update on the North Wing and where this project is from 2 months ago or a month and a half ago. And then we'll start walking through things like how I approach foundation modeling, how I approach structural framing, headers, studs, not really studs, but we'll talk about why studs in a second, and then roof rafters, floor joists, and so on and so forth, and some of the tips and tricks along the way. Hey Matthias, what's up, man? Charles, awesome, great. All right. So where's this project at? Let's look at it. So here's the structural, but we'll jump out to the overall building model here. And so you can start seeing, if you have been following along with this project, then you may notice some differences from before as I've been sort of refining the design, making it more practical, thinking about the fact that I'm going to be building a lot of this too, and my skill sets and how complicated some things want to be, but also how much it's going to cost. So trying to make things a little more practical, a little more constructible, so you start to see some minor tweaks along the way. You can see if I flip around here, still kind of deciding some things about the materials and so on. But one thing you'll notice is that this dormer shed is kind of more in line with the actual exterior wall. It's no longer offset. There's this larger front entrance porch. One thing with split level ranches, which is what this house is is that the entrance is extremely awkward. And so one of the things that I was playing a lot with is how to make it something reasonable, give us this big porch, but also try to get it so that we can still enter at the current location, which is actually the stair landing. So this is kind of where the project is. If I flip through, I've also been pulling together sheets for a pricing set, and that'll be a different episode where we talk about sort of the process of GCing your own projects, whether you're an architect or not. So I'll just flip through a couple of sets of drawings. Here's the basement plans. Here's the first floor plans. Here's the roof plan. And then we jump into some of the sections and details. And then we jump into the structural drawings. So here's some of the structural drawings here. So that's kind of where the project is at. If I jump over to structural drawings, let's go back to the 3D views. We can talk about structure. So here we go, building framing. So today's episode, we're going to be focused specifically on structure. I'm not a structural engineer. I'm a licensed architect. And so my experience with structure is as an architect. So the structural engineers out there, bear with me as we go along with this. be kind as we go through it. But I think when it comes to this type of project, which is a small scale residential addition, a lot of times, as the architect, you are the engineer on a lot of these projects, right? Depending on your location, requirements, and so on and so forth. But a lot of times you are the engineer. And so doing things like modeling the structure, modeling the plumbing, modeling the electrical, and even some of the mechanical piping or ductwork and so on and so forth is extremely valuable. And sometimes it's what you do, right, as a residential architect. So my approach to structural framing has kind of, in this type of work, has kind of evolved a little bit over the years. So if you followed me and seen the first phase of this project, which is the actual studio that I'm in here, which I'll spin around to the other side, is this guy right here. You can see this is a previous phase. So if I move through it, you'll notice a couple things. So first you'll see I actually have all the studs modeled, right? Including the plates and sole plates. But then I also individually modeled the headers and the jack studs and all that stuff as part of kind of this individual modeling process, right? So I basically I stick built it, right? I mean, I individually stick built it as needed. And so that's great, and honestly, it worked out fine, and I've got really no complaints with it, other than it obviously takes a little bit of time. And you kind of want to be pretty refined with your design before you start modeling studs, because the process of modifying those openings and so on and so forth is not easy. You're basically doing a beam system and moving it around, and so ideally you want to be more refined with it. And so as I've sort of evolved with some of these projects, and what information I actually used from it, the studs was probably the least important of the information. Yes, it was helpful for materials and understanding length of studs and how many studs I needed and so on and so forth. But at the end of the day, the really important things were the floor framing, the headers, right, the window and door headers, the roof framing, and then some of the more miscellaneous specialty framing, like maybe the rake and rim, or the rake, the fascia boards, all that good stuff. The more important structural elements. And then it's pretty easy to figure out a general idea of studs based on area, square footage, and so on and so forth. And so the weighing off the time it takes to model the studs and maintain them as well, versus the approach that I'm going to show you today, it's a pretty simple answer when you start to see it. And so let's start from the ground up, and we'll sort of work through how I approach this, and I'll show you some tips and tricks. So what I'm going to do is I'm going to turn on the section box, and I'm going to work from the ground up, and let's just do a first floor sort of thing here. So if we look at this lower level, hey Peter, Stacy, hello. We've got a lot of fun people here, a lot of people back that I recognized from before. So the one thing you'll notice is I don't have studs modeled, right? Actually, I'm going to move my head to this side for you guys. Sorry if I freaked you out there, but just so in case you wanted to see the whole project browser and so on and so forth. So one thing is you'll notice I do not have the studs modeled, right? I do have these plates modeled, right? The sill plates and the and whatnot. And that's, I'll tell you why I did that in a minute. But what you'll notice is that I don't have the studs modeled, but I do have the headers, the structural headers, and obviously the posts. So anything really structural modeled. Over here, you'll notice these are individually modeled as structural members, and I'll tell you why in a second. This is actually a family. And so the first thing I want to talk about today is I want to talk about this header family, because I think this is a huge efficiency improvement to before when I was stick building all the headers. And I will credit Alex Gore from F9 Productions, because this is started as his header family and I've modified it. And actually, Alex, if you see this in the future, I'll shoot you an email. I'll send you back this one because I know we were talking about adding some of these parameters in before. But what this header family does is, and there's lots of ways you can create this family. There's lots of things you can do with it. So this is not a one size fit all, but this is what kind of worked for me. So if I create similar, it's a face-based family. And so if I go, if I select place on work plane, and I'll place it on basement level, and I click and drag, okay, what you'll see is it's a line-based family, right? So I can push and pull it, okay, and it's doing, it's expanding and contracting with it. There are some great things within this family where you can add a sill or get rid of a sill. So if you have a door, you just turn the sill off. You can add number of king studs, so I can increase the king studs to, X, Y, and Z, whatever, whatever you need those king studs to be. But what's really cool about it is, and let me just make sure if I go to edit family, I'll show you a little bit what's going on the inside of this family, is if I look at this family now and I go to my elevations or sections, there's a section here. A couple things. First, it's got these members in here, and you can see I've got these X's modeled in. So when you cut this through a section, it actually does look like that. But I want you to pay attention to the distance between here and here, right? The distance, the beam, oops, the header depth. So if I go and I change the width of this, where's my length? If I change the length of this to 3 feet and click apply, look what happens to the header. Okay, let me zoom in a little more so you can see. Okay, so if I change actually let's do it via 3D view, because I think that'll be a more telling description for you guys. So there's section 1. I tile this. Okay, so let's take a look at this guy, right? So if I scroll this forward, let's not do it that way. Let's change the length again. I change it to 8 feet, click OK. Take a look at the beam right here. Click OK. You'll notice it rises up. So basically what's happening here is this header family is adjusting based on the length of your opening, right? The length of your opening. So if I click into this guy and I zoom in, I'll give you a sense of what that formula looks like. It's actually pretty neat, and you guys can probably use this for lots of different things. Okay, so it's really just a set of if statements. Let me expand this a little bit. Okay, right here. So if the length is less than 3 feet, 3 foot 11 inches, then it's a 2 by 8. If the length is less than 5 foot 11 inches, then it's a 2 by 10. If the length is less than 7 foot, 11 and a quarter, and then all else 11 and 7/8. So it's not picking up everything, and I could make this extremely complex, but basically what it's using is, if I go back into my project here on my structural sheets, let's go to sheets here. I'm still kind of getting used to having sheets and views separate, but I do kind of like that in 2025 if you guys haven't dealt with it. So if I go to my foundation plan, right, I have some notes right here. 0 to 311, 2 2-bys, 4 to 5, 2 2x10s, et cetera, and then 6 foot, so on and so forth. So basically I built that into this. So when I'm going around, the first thing I do is I can go in my floor plans. I don't even need to be in 3D, right? Here's my family here. I can just go around, click this guy, and just place it in all my openings, right? Right, so, and actually what I'll do is I'll place them out here and cut a section through it so you guys can see. So by doing that, you could see, let's turn this on, right? You could see here's my header families, and notice they're already adjusting based on it. So, and then within that, you could set the head height and the sill height, and there's a bunch of other stuff that we could do within that. But just like that, you can quickly go around your floor plan and start laying out the major header information, right? Jim asked if those are based on snow loads in your area. Yes, those are header. I live in Connecticut. This is for Connecticut. Those are my typical headers for what I would do in Connecticut for residential. So yes, your header size may be different, your diagram may be different, but I wanted to show you the formula because the formula is actually, and maybe I'll post this in the description afterwards. What's cool about the formula is if you're trying to understand how do I show between 0 and 4 feet, and then 4 feet and 6 feet, and then 6 feet and 8 feet. How do I show that in formula? And so I even struggled with that for a minute because it's been a while since I've done that. And the way that you do it is, if I go back to that formula for you guys, is you actually don't worry about the in-between because remember, it's an if statement. So it's looking for true and false essentially, right? It's a Boolean. And so basically, if I scroll through this, so if the length is 3 foot is less than 3 foot 11, so basically between 0 and 3 foot 11, we're going to use 2 2x8s. That may be much, right? I think if it's even less, we could probably do 2x6, but whatever. That's going to be 2 2x8s, right? That's going to be our minimum. And then so then the next phase is going to be okay between 3 foot 11 and 5 foot 11, you would just say length less than. Because remember, it's doing the conditional statements along the way, right? So 2x8. So you don't need a greater than or equal to. You don't need to have like this weird less than, or less than, greater than, etc. Because these are if statements that are conditionally going along the way. And so it's looking for if it's true, and if it's not true, it's moving on to the next statement. So then it's not true. Let's say it's more than 3 foot 11. Then it's going to say, okay, now what do I do? Okay, if it's less than 5 foot 11, I do this. If it's not less than 5 foot 11, I do the next thing, right? And so you're kind of going along. So that's, take it for what it's worth. But I think that's a super valuable lesson in family creation and how you can create something that essentially needs to be a greater than greater than or equal to, or between, right? Between 5 and 6 feet, I need this. Between 6 and 7 feet, I need this. Between 7 and 8 feet, I need this. If you just do the less than, if the length is less than 5 feet, and then if the length is less than 6 feet, you're giving 2 results for that. I'm not sure what Peter, I'm not sure what you're asking about intellectual property, but potentially, I guess, I don't know. Okay, so that's the header family. So what's cool about that is, if I go back to my framing model, and you can see here's my header families here. And the reason I do the header families first is because it's the quickest way to see what you're dealing with as far as head heights and windows and how you want to approach them. If I delete these, you'll notice here I'm playing with the idea of having 3 individual windows instead of a larger opening, and where this could easily be a 6 foot opening with 3 windows. Let me get the section box tighter so I could adjust it for you guys. But because I quickly threw in these headers, you can start seeing how those headers are going to be impacted by the floor to floor height, right? This is the basement. So if I cut a section this way, whoops, let's go back a little bit. You can see depending on what I do, I'm kind of limited with my space, and then you might have to sister the headers up. I did have this a little different. I had the windows taller at one point, and so I was kind of playing with that. Whereas over here, what you'll notice is I actually stick built this because there's not enough room for the headers. Let me jump this back. And so this header will be basically sistered up with the rim joist, right? So that's kind of what you're seeing in there, and then you're just seeing kind of stacked stuff there. So first sort of tip is this header family. Either create your own, or if you are interested in this family, but also this project and the template, I will say that you members of the BIM After Dark community, which is a private community for us Revit users looking to expand our knowledge. I'll show you right here is you do have complete access to this residential template. You can see it here. as well as that Revit family I've already shared in there. And then this sample file for this project will also be in there. So if you are interested in that, I know I'm going to get a question in the chat about it. If you're interested in the header family or that Revit template family, Revit template, then head over to community.bimafterdark.com and sign up. And coming out with me and a bunch of cool dudes and ladies in the chat there, in the community there. Okay, so headers first. Why did I put sill plates in there, even though I didn't do studs? I'll tell you why. Because if I go to my building sections here, oops, I wasn't showing it, sorry. If I go to my building section here, what you'll notice is these sections look pretty good, right? There's a lot of graphic information here, right? Well, normally you may be thinking, well, yeah, you put a whole bunch of detail items and a bunch of cool information. Well, check this out. If I was to just make a brand new section through this, okay? So I'm going to cut a brand new section right through the building. This is not duplicate with detailing, etc. I'm just going to go into it. I'm going to change the scale to, let's say, 1/2 inch for now. And now you'll notice if I zoom in, check this out. There's my sill. There's my header family, right? There's my plate, right? There's my sill. There's my header family. There's my plate, and then there's another plate there, right? So essentially, I'm doing two different things, right? I'm making it so that I have a better understanding of the design of this project, right? Once you put the headers in, even the sills can be helpful too, because if you put a double top plate or something, maybe you start to see what's happening with the dimension there. But I'm also making my sections, and I don't have to worry about using detail items, right? So sills, probably not a huge value add as far as design, maybe not even for the GC side of being able to look at the length and so on and so forth. But damn, is it nice to be able to cut a section anywhere you want along this wall section. And you have a sill plate, you have a top plate, you have your headers, everything in there. And all you're doing is basically filling in, the information. And actually, I'll show you real quickly if I hit the section template, you know, how quickly this thing turns just like that. Just by hitting it with one section template, you'll notice I didn't draw a single detail on this. Okay, this is all three-dimensional items. And honestly, you can probably get away with this as is, as a building section ready to go for this type of work, right? And so that's the whole point, right? It's twofold. It's how much do you need to model for the sake of understanding the design, for the sake of maybe the structural plans, but then also what can help you also develop your construction documents later on. So I can confidently cut a wall section basically anywhere on this edition and have essentially 90% of the thing graphically shown there, which I think it's pretty cool, right? So that's pretty much the only reason why I have the sill and sill plates. Again, there's some nice things about trying to figure that out, but for the most part, that's basically why I have them there. Joe Buchek asks, would you be angry if the builder doesn't put everything exactly where? Not at all. Well, it depends, I guess. It depends on the importance of the structural integrity of that object, right? You know, you'll see when we get to the roof and floor framing, obviously the field framing, what they do in between, there's flexibility to some extent, right? But maybe if there's a LVL or a strand beam or whatever, right, that there may be some important things that you want to maintain. But remember, in this case, I'm the GC, that I'll be hiring some trade partners to do other work within it. So for me, it's super helpful to work all this stuff out, right? Okay. So we talked about the headers. We talked about the, oops, wrong building section there. We talked about the headers. We talked about the sills. Real quickly, I know this is something that maybe isn't super important to everybody here, but for the foundation, I know I get this question quite a bit. And there's actually a video I did like 15 years ago for step footing that still is gaining tons of traffic today, which is pretty cool. There's a lot of different approaches that you can take for a stepped footing. And so what you'll notice here is I have 4 different wall sections that are split with a strip footing that's been extended. Okay, so if I draw this over here, oh boy, where did I draw that? Let's try this again. Okay, so where's the top of this thing? Hold on, top offset. Oh, what's going all the way up there? Let's do basement, sill. Okay, there we go. All right, so I actually prefer this method. This is just my preference. There are different ways you can approach it. And so what does this mean? I just have 4 different walls, and then I have a strip footing, and then I change the offset of of the footing, right? So the way you create this is, again, I'll split. So not split between. Try that again. We'll do a split. Don't delete the intersection. So SL for split. And I'm just going to split this a couple places, right? So now I have 3 wall pieces, and whether you have levels or not doesn't really matter. Let's just do this. And then I'm just using a strip footing. So create similar, place it here, 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 and here. And then I'm offsetting this this footing by 1 foot, 1 to 2, whatever that ratio is. And you can see they clean up pretty nicely, right? So I'm just going to pull it. I'm being loose right now, but you get the idea. Okay. And so that's one way to quickly create a step footing, right? That's just kind of the way I like having these 3 different walls, because then each wall segment can also generate the information as far as on the left-hand side for the properties of base, offset. There's different properties within it. The other method you could use is you could have one wall. Let me undo this here. So let's just do one wall, and you could modify the profile, right? So let's do this. And I could do like a 2 to 1. I'm just going to rough it for right now. Right, so I'm just modifying the profile and click finish. And then I could apply the footing, and you can see it does that. And then each of these footings should be adjustable. Well, maybe not. I thought there was a way to adjust the extents, but maybe there's not. So a couple different ways you can approach it. Like I said, I'm a pretty big fan of the splitting the wall. I like having each wall being individual, so then I can also register the information here. Like, for example, 4 foot 6 3/4 is the unconnected height. This one is 5 foot 6 3/4. This one is 6 foot 2 3/4. If you do an edited profile, then it's going to just give you the biggest extents for where the constraints are on that wall, which may not be the best when you're looking at sort of downstream use of the model and so on and so forth. Okay, so that's the foundation. I don't think I need to talk about the sonotubes. Those are just simple concrete round columns. You could, I guess, use footing family too. It doesn't really make a huge difference there. And I do also have, and actually maybe I should show that too, because you might be interested in that. There's a thickened slab under this bearing wall in the middle here. And so this is also something that you can take a couple different approaches to. You can see here is I'm actually using a floor, and then a thicker floor, and then I use the slab edge to do this haunching. You can make the whole thing with a slab edge and have 2 slabs. You could do some form of a foundation or a footing. Honestly, there's many different ways you can approach it. I like this one because graphically it showed really nice in the structural foundation plans, because you just have that line that you could use. Let me get out of here. So you can see that line that you could use from the 2 slab edges that represent sort of that haunch slab. But that's really completely up to what you guys want to do. There's plenty of ways to sort of approach that. I think I could also have used some form of a footing family and maybe even attach it to the bearing wall, which may not be that bad of an idea. Modify some form of a strip footing family. So hey, if anyone else has any ideas on how they approach this, I'd love to hear it. But that's kind of how I approached it for this particular project. So we've talked about the header family real quick. We've talked about the footers, or the footings, and the foundation walls. And so now we're going to jump into some of the wood framing and how you would go from taking an architectural model that just has walls, floors, and roofs, and creating a model that you saw before, which looks like the stick-built families. Before we do that, I did want to take a quick moment to recognize our sponsor for this season of BIM After Dark Live, which is revitfamily.biz. So I'm going to roll the ad reel real quick, and then we'll talk about it, and then jump right back into it. So revitfamily.biz, if you guys have watched this channel for a while, you may maybe familiar with some of the content. Brenton Weiberg has been a guest on the show. But what you're going to see throughout the creation of this particular project is that in my template and in my projects, I use his cabinets, I use his doors, and I will be using his electrical families, all from revitfamily.biz. Some incredible content, especially content for residential Revit architects and designers. And so if you're interested in checking it out, head on over to revitfamily.biz, use offer code 20 RevitKid24. I'll put this in the description as well, and you'll save 20% off of anything. And so in future episodes, you will start to see some of these families in action, but they are great families for what we do. And Brenton is an awesome supporter of the show. So thank you guys, thank you, Brenton, for supporting this series. Okay, so now let's jump into our framing stuff, our good old framing. Also, one thing I will show you, which I think is kind of nice when it comes to this type of work, which is small scale residential, is and I always kind of have diagrams if you guys have seen my previous ones, but I like this approach to diagramming. And again, I think I'll thank Alex Gore for this one. I feel like he might have shown something similar. But basically, I have a 3D axon of the plan that you're looking at. This one I did 2 views because I wanted to make sure you can see the front and back of this step. But you basically have the floor plan here with information, and then you have this 3D axon on both sides. Oh, looks like people are using the families there. So awesome. Yes, I will be using the electrical families in an episode to show the electrical rundown. They are phenomenal because they are built with the purpose of both 3D and documentation. So they're awesome for that. Anyways, sorry. I think that was, who was that? Lobo ZX. All right. So this is something that I do a lot with, and you notice if I went through my set, is adding 3D views is extremely valuable. You have the model here, and I'll talk about when it comes to the GC side with the bidding and getting information to contractors. Not only do I do this, but I'm also using a form of being able to share the actual model with them so that they can see and understand the work better. And so if I go to the first floor framing, what you'll notice is same idea, right? We have now just the first floor framing showing, and then we have the actual first floor framing plan here with the information. Okay, so let's jump to the 3D view for this first floor framing, and we'll talk about how I approach this. And I'll actually just slide up so we're only seeing first floor. Okay. It might get a little convoluted because of some of the lower roofs, but we'll just do this. Here we go. So you can see here's the header families here, right? You can see that guy there. There's another header family here, another header family here, another header family here. I've got my my sill plates, my top plates, all that good stuff. But then if you just look at the field, these are just simply beam systems. So anyone who's not familiar with beam systems, I'm going to show you real quickly how to make them. But they make life they make life very easy. And so how this works is I would go up to structure up here on the top here, and I go to beam system. Of course, you need to have your joist families loaded in, and I'll talk about my joist families and how I've modified them. And then it's as simple as just drawing a sketch. I usually have, essentially what I'll do is I'll have a floor initially. Here, let me just draw this first, and then we'll get into that. So I'm going to do the beam direction here. And then on the left-hand side, it's real simple. You can choose what kind of beams you want or joists you want. And so you can see I'm going to use dimensional lumber, let's say the 2x8s, right? 2x8s, they're going to be at 1 foot 4 inches on center. And then I'm going to click finish. And then, of course, I didn't have those on the right working plane. So let's try that again. I had those set to the basement. So let me set those to first floor and click finish. And you can see here's our beam systems. And so ideally you want to maintain the system as long as humanly possible. But you can also break away from the system as well. But what I wanted to show you before I sort of break away from the system and show you how I do things like the bridging and some of the other stuff around the edges is there's another thing that I've done to these families, which I've talked about in other videos, is if I was to, again, cut a section. So if I go back to my floor plan. Okay, so if I was to cut a fresh section in this direction, and go into it, what you'll notice is, let's change the scale to 3/4 inch. I zoom in. These are our beams. So, and you may have seen this video on my channel. If not, now you're seeing what I do here, so here's my floor, okay? So here's my finished floor, here's my subfloor, and then here is my my beam system. So when I initially created, I actually have a couple different floors in the template. So if I pull down here, I do have floors that have the structure as their thickness, and that's usually where I start, right? Which is your typical, if I click this, right, it's got the floor, it's got the subfloor, it's got everything in there. Before I build my beams, I transition to a subfloor and flooring model, where I have two different floors. Sometimes it's the same, but usually because this has a bathroom and wood flooring and stuff, I actually keep it separate. And then from there, you can either host your beams to your beam system to your level, or once you flip it to a subfloor model, and this is for the roof sheathing as well, you can also host it to the sheathing, the underside of sheathing, which helps because, especially on roofs, we'll talk about that in a second. But you'll notice as I cut a section, right, and then if I flip to my section view template, it gets even better. There you go. You can see now I've actually got all these beams. These are real beams. These are not detail items. So not only am I able to sort of figure out and create a structural framing plan, I'm also able to figure out, I don't know, how I want to structurally design this building, but also I'm able to make my sections, pretty much in one click, which is pretty awesome, right? And so let's go back to the framing model here, and I'll talk about a little bit how you want to get to intermediate pieces and so on and so forth. And so this is pretty easy, and you could do this and probably get 90% of your flooring modeled, flooring structure modeled this way, right? But let's just say you have an opening in it, or maybe you want to do the rim joist or so on and so forth. What's kind of cool about this is, and you could simply go to structure and draw a beam, and do exactly, oops, that is not a beam, that's my header family. You can go to beam, you can flip to, your 2x6 or whatever it is, and you can kind of draw them in there as long as it's right. So you could do that as well. But what's nice about when you use a beam system, let's say there's an opening here, you can also, and the reason I sort of do this is because if you'll see what I'm doing on a roof, it's using the host of the beam system. So if you have it hosted to a reference plane or a roof or something obscure, now you have something where if I copy this, right, I'm able to copy this beam. It's not locked to the system anymore, but it's hosted to the same host as the system. So now I can rotate it 90 degrees, right? I can rotate it 45 degrees. I can do whatever I need to do. And then I can take the beam system if I want to too, and I can split it. I can unpin it and split it, and I can do things like, make openings in my beam. I can double them up. So let's just quickly make an opening here. Let's just say this is an opening, right? Which opening's probably gonna have double. So I'm just using copy. I'm just copying it. Same thing here. So I'm taking this pin beam, I'm copying it over, taking this pin beam, I'm copying it over, and just like that, right? We have an opening. Okay, so that's kind of why I like this approach, and you'll see when we do the roof especially, because now I've still got my beam system, right? I'm still flexible to that extent, but now I have objects that are hosted to the same host as the beam system. It just makes it easy to quickly run through and do things like I just showed you, where you sort of split around and make an opening there. Same goes for the rim joists, the rim boards, whatever you want to call them, and so on and so forth. And so with that, all I'm doing is I'm simply just modeling a couple beam systems. Right, so this is two beam systems because I have a bearing wall and they're kind of overlapping and cantilevering through. And then the bridging, so this is one of those things where I'm showing it as 2x bridging. It probably will end up being some sort of metal strapping. I don't actually know exactly what we're going to do for bridging yet, but one of the things that I wanted to do was just kind of show it, especially on the bearing wall, because that's something that I wanted there. And the bridging is exactly what you see here. There's other approaches you could try and take with joining and seeing how the geometry works there, but really it was just a matter of, that was just a simple copy, whatever. One thing that I will say though, for anyone who's just maybe starting and getting used to using beams in Revit, A nice little tip I'll give you guys is whatever you do, try your best to utilize the blue dot for dragging your beams. This is might burn you here and there because it's locking to things, and so sometimes it'll get off skew. But I promise you, the second that you start messing with the arrow to do something, and I'll show you exactly why. So if I notice how there's a blue dot and there's an arrow. Hopefully you guys can see that right at the end here. Okay. If I move the arrow, so I'm gonna try my best to move the arrow here. So if I move the arrow to here, graphically, this looks fine, right? But you'll notice how there's a blue dot out here and there's arrows back there, right? That's called an extension. And so if I look over here, you can see end extension is 11 3/4. That thing, if you copy this beam around the project and you start messing with it, this thing will destroy you. Because you'll notice if I pull the extension, watch what happens. This goes with it, but then I go like that. And you're fighting between the actual point, which is the framing end of the component, and the geometry extension, right? And so the extension exists for a reason, for things like coping and other stuff like that. But as much as possible, I urge you to try and keep your extensions to 0 and try your best to move beams using the dot and not the arrows. Okay. Actually, Matthias just asked kind of when do you use the arrow? Yeah, the arrow is used for very specific things, like you said, like if you want to do cut length or coping and stuff like that. I think that's kind of where it comes into play. But even that you can use via properties instead of grabbing it. But as much as possible, you want to try, because like I said, the second you do this and you pull it via the arrow and you have, like, say, a dot there, it'll chase you around the building and it'll just drive you nuts, right? Because again, if you do this, then you're like, oh my God, why is that going there? And why is this going there? And it really it's take it from me. That's what you want to do. You want to try your best to use the dot, not the arrow, when you're moving. Yeah, the working point, whatever you want to call it. I think it actually says in Revit, if you're looking at it, it calls it the component end, the framing component end. But yeah, there's no way to turn the arrows off. That's just a built-in function of Revit. You can tab though, right? So using the tab key, you'll notice I can tab. There's the dot, there's the arrow, there's this. You can kind of, especially when they're overlapped. So here you'll see it's joining with that and it's pulling it back. That's fine. If you're out of it, it's going to align. If you want to make sure you're selecting the right thing, I'm tabbing between, and you can see on the bottom left, it's showing between two different things. So tab is the way you want to make sure you don't select either or. Okay. So floor framing is easy, honestly, right? You can use a work plane, you can use a floor, and you basically are just drawing at X, Y, and Z spacing. Here's my stuff, and then you're kind of framing it along. It makes it, honestly, it's probably the easiest thing you can do because it's flat, it's simple, it's straightforward, right? Of course, Joe said, yeah, that thing is, whew. I can tell you right now on the sill plates, for example, that actually got me a couple times even on this project. I think you can see here. Yeah, this one, look at that. I even have it screwed up on this one. And I must not have fixed this one. Notice the extension ends. So basically what I do is, so this one has extension ends that were expanded. I'll click this thing back to 0 and 0, and then I'll make sure I take the point or the dot, the control point, whatever you want to call it, and I'll extend that to where we want to go. And you'll see even, it just even controls better on the ends there. So I did that with these. You can see this is what happens when you copy it along. I actually have these sill plates screwed up from the lower level. Okay, so now let's talk about roofs. Okay, so roofs. Good old roofs. I'm gonna get rid of this guy. So roofs are similar to floors, right? But obviously the challenge is they're slanted most of the time, right? And so it seems daunting in Revit because, beam systems are flat. They're worked on. If you've ever dealt with them, you dealt with them like I showed you there. But roofs are on an angle, they're sloped, and how do you make it work? And so my approach is similar to floors in the sense that I start with an actual roof, and then I take two different approaches depending on the project and what I want to do. And so if I turn roofs back on here, so let's do this. Let's turn roofs on, and I'm going to move it out to here. So I'm going to take these three. I'll do the simple roof here. So these are actually two roofs because of the way I modeled it. So let me grab the roofs. I'm going to move them out here, and we're going to kind of do this thing from scratch, or not. Let's try that again. Roof. What? I probably should have read that error, huh? Oh, I didn't copy the skylights. Okay, so here's my two roof families, right? Or my roof system families, whatever you want to call them. Okay, so you can take two approaches when it comes to now modeling the structure. Notice I use the roof that has a 2x8 built into it, right? So if I go to the structure of this and I go to expand, you can see it's a 7 1/4, 3/4, 1/4 inch, whatever, right? So it's got the whole sandwich in there. And a lot of times, which is what I did on this project too, is I will actually leave the roof like that for the sake of the elevations and graphically being able to turn off the rafters as needed. Because the one thing I'll tell you with roof rafters is coping and and getting the plumb cuts and everything is a nightmare, right? And depending on what you're doing, it may not be necessary to get the full value out of modeling the roof. And so if I use the roof object and keep the thickness, I can turn off the structural framing in certain views, like elevation views if I want to, and utilize the two-cut plumb, the fascia, all the stuff that's great with the roof tool. But then I can take advantage of the structural drawings and the diagrams and the section cuts having the actual roof in them. And so the only sort of negative to this, using it this way, is that you're being forced to host the beam system to the top of the roof and then use an offset to get it to the bottom of the sheathing. If I was to use a roof type that is just the sheathing only, so you see I have sheathing only ones here. So if I click sheathing only, now I can actually host to the bottom of this and not have to do an offset. Okay, so let's just first do the offset and then I'll show you without it just so you can get a sense of it. So once you have your roof designed, or maybe it changes, it's okay if it does, but once you have it generally designed, then it makes the beam system part of the roof super easy to do. So if I go over to structure, just like I did with the floor, I go to beam system, right? The difference is when I set my work plane, which is up here, right? Click set work plane. I'm not going to use first floor. I'm not going to use roof. I'm not going to use a level. I'm going to pick my plane, which is this option down here. I'm going to click OK. And now I'm going to pick the top of this roof. Okay, so now I'm working on the top of this roof. That is my sketch plane. And now there's different ways you could sketch it. I'm just going to quickly tab around the edges here, set my beam direction that way. We're going to say 2x8 dimensional, 1'4", click finish. And now you can see we have our structure. Okay. Of course, it's actually going off of the asphalt or the asphalt shingles, right? It's going off of the top layer. So if I zoom in there, you can see there's that little gap there. So this is kind of where it's a little bit of a downfall, but honestly, it's not that big of a deal. This is kind of how I approach it anyways. So if you know the thickness of your sheathing and shingle layer, so for this project, for this one, it's a 1 inch. What you can do is you can select your beam system. I'm sorry, you have to select the beams within the system. So you have to actually select the the joists within the system. And unfortunately, there's no way to, similar to like, which would be kind of cool. So like when you have curtain systems, if you right click a mullion, you can say select all mullions on host. For some reason, beam systems aren't that way. It would be really cool if you just say select all beams within the system. Maybe there's a way, I don't know, but I've been using Revit for a while and I didn't see it. So I'm just gonna drag select, go to filter and select my framing. Okay, you don't need to unpin them. They stay part of the beam system, but you can change their Z offset right here. Okay, so I'm gonna change that to -1 inch. Click apply. And now if I go in 3D, you can see, so now they're actually, even though they're hosted to the top, and hopefully you can see that double dashed line that's coming up, they're hosted to the top, but they're offset the thickness of my structure. So now I have the ability to show the roof if I need to, but then I also have the ability to show the framing if I need to. And because it's hosted to this, right, If I change the pitch of this roof, you'll see what happens, right? They're adjusting to it. The sketch didn't adjust to it because I didn't lock the edge of it. I would probably have to lock the edge of it, but that's an easy fix. But what you'll notice is that now it's actually flexing, right? It's flexing to the pitch. So it's hosted to the pitch of this roof, which makes it super easy to then use that as your object. Right? Obviously, if you delete the roof, guess what? You're screwed, right? Right? You have to remake your beam system, or you select your beam system and you have to rehost it to the new roof. Okay. If you were to do the sheathing only method, so if if I go to, this is just metal roof and sheathing. Let me move this up so it's along the way. And I do see there's a couple questions. I'll get to those in a second, guys. So this is now, you can see this is just the metal seam and sheathing layer. Then you could just do a beam system and you could host it to the bottom. So I can pick plane to the bottom of this roof. Do the same thing, tab, go around, do that thing, click finish. And now I don't have to do an offset, right? Because now it's to the bottom. But now you have to model the fascia and the eaves and the rakes and all that stuff. And so you'll notice over here, right, I'm using the roof element. Actually, let me go to 3D, the architectural view. You'll notice over here, I'm using that roof element to help with my elevations, right? Because now I have a fascia here. You can see I have a fascia here. I have a gutter here. I have this stuff going around here. There's a fascia, there's a gutter, right? So on and so forth. So then I could just turn off these framing, even though you can see it here. I could turn off the framing in these views, and I don't have to worry about trying to do that cutting of the gable ends and the coping and all that good stuff. Oh, no beam systems for LT. Yeah, sorry, Revit Lite users. If you're a Revit LT user, I guess you can't do this. So I'm not really sure. Because I don't even know if you can model a structure like a beam itself, or is beams available but not beam systems? Because that'd be really goofy. But sorry about that. Okay, so then when it comes to roofs, let me go back to you. Sorry, let me jump around here. Okay. So as you can see now it makes it pretty easy to actually model roofs along this edge here. If you want to talk about these rake or gable, whatever you want to call these at this point, because this is kind of like a false one, but you can actually see what I did with this is it's actually a beam system in the other direction. So let's just pretend that we want to go with our outriggers to the eave here, the rake here, whatever you want to call it. I can do the same thing. I can do a beam system. I can set it to this guy, right? So now it's working on it. I can do a quick sketch to wherever this needs to be, but instead I'm going to do a beam direction in this direction, right? Click finish. You can see there's my little boards, and then obviously I could select those and do a 1-inch offset. And just like the other ones, right, these are also still hosted to the roof, right? See what they're doing there? They're kind of moving the roof. So as long as you do that and you maintain that host, you have the ability to build this stuff within it. Somebody's mentioned some of the terms there. When it comes to framing, I've worked with enough contractors in my life now to know that there's just so many names for everything. So I apologize if you get offended by what I'm calling some of these framing elements. So now you can see you could quickly build this in, and similar to the floor, right? I can now take one of these pieces if I wanted to, and I can copy it along here, and I believe it'll hold. It'll maintain. Yeah, see, it still maintains the host, right? So now I can copy this if I needed a double. If I needed, and this is the part that's really cool about instead of modeling a beam individually, if I use copy. So let's say we put an opening in here. So I'm just going to do a copy, and I'll do copy it over, right? I'll unpin this so I can split it. You can't split it unless you unpin it, which means it's not part of the system, but you get it. Grab my dot, not my arrows. Okay. And now watch this. If I copy this guy and rotate it 90 degrees, right? It's still hosted. I'm using the arrow too. Don't forget the arrow. I mean the dot, not the arrow. It's still hosted. And again, I'm just using copies and rotates here. Okay, so I'm not going to be perfect because we're live now. I'll copy these two down. Right, so look at that. I just made a quick framed opening Okay, but again, because I copied it from the beam system, look at this. It's flexing with it. See that? Right? And so because you start with this host and everything's hosted to the roof edge, it makes it super simple to be able to make things like openings and double studs and ridges and ledgers and whatever we want to talk about from there. Okay, and last but not least, and I will check your questions in 1 second, is if you're dealing with things like valleys and whatnot. Okay, so I believe I have my valley over here, which I actually didn't model the roof there, but let's just do a different valley. So we'll just it's really just a matter of modifying the sketch, right? So if I go to the sketch here, let's just pretend that there's a valley, I don't know, like that, right? So your sketch is going to follow that, and then guess what? On your valley side, you're just going to host it. You're just going to host it to the valley, right? So, or to the other part. So let me put a quick roof in here. And I know I'm going fast, but it's just because I want to. All right. Give me the roof. Come on. Roof by footprint. Oh, I don't know what I'm set to for work plane. Let's try this again. Let's set it to roof. And we'll do a quick roof like this. Turn these off. Of course, why would it line up? Okay, so as you can see, we've got ourselves a little valley going on here. We can talk about how you want, modeling roofs at another time, but this valley is intersecting this, so we can join it if we want and see where that line is. You can see there's the line there, but really all you would do is you would create a beam system just like we did before. Set it to this would be the underside, right? Set it to the underside of this, and you would essentially just sketch only that triangle piece, right? So I'm going to do something like this. And I think that should be good. Oh, let's just do that for now. Click finish. And you can see now you're able to sort of model this. And remember, because you're hosting it to this, if I pull this down, the length is going to screw up because I didn't lock anything. If you lock it, it'll work fine. But you can see what it's doing is it's flexing and moving along with it, right? So that when you start understanding that concept, with floors, I would suggest you probably want to host to a work plane or a level, I should say, because it's flat. That's what it's going to be. If you wanted to, you can use underside of sheathing, but it doesn't really make a huge difference because you're flat. With roofs, that's the key, right? It's utilizing the roof as your work plane, but remembering that has to be your work plane forever, right? And so. And then from there, you can be flexible and modify it as needed. As I showed you there, you can copy, paste, rotate, split, do whatever you want. But as long as once you start with the beam system and you pull all your other auxiliary structure away from it, all those auxiliary structures, because they started from the beam system, they're hosted to your roof and they're good to go. Have you tried any plugins that's supposed to be frame length? Yes, I have tested out, or I shouldn't say I'm a user of MWF framing, with their metal framing tool. They do have a wood one, and I have also used the AgaCAD tools. They are great for getting a layout based on objects that exist in Revit. They are not great at maintenance. And so what I mean by that is if the project evolves and things change, a lot of times it ends up being delete and refresh the whole thing. And again, as you can see, framing, roof framing, floor framing, and then headers, if you're doing that, you're doing most of what you need. The value in studs for architects especially, I don't think it's there. Maybe as the contractor, and again, I'm doing both on this job, so there may be value there. Understanding some of the stud lengths, the number of studs, the so on and so forth. I'm going to have 13 studs that are over 12 feet and 10 studs that are over 10 feet, etc. Yeah, that I could see the value there, but I just don't. Yeah, I don't. It's not worth the time and frustration that I've dealt with on those. But they are great for if you're someone that does this every day. If you're a framer and you're modeling for the sake of materials and even prefab or something like that, then sure, I would say look into it for sure. All right, cool. So here's to framing. So that's basically how I laid out this whole thing. As you can see, it's when you break it down into those kind of 3 little pieces, it actually ends up being pretty easy, pretty simple to get through. So if you're interested in the template, the header family, the sample file, etc., head on over to community.bimafterdark.com. Thank you for joining me tonight. Come back next week. I'm probably going to do it on Monday night. I don't think I'm going to be able to focus on Tuesday night. But maybe I'll do it on Monday night. We'll come back, and I got a whole bunch of episodes planned to share with you on this project, including some of the GC stuff, including some of the other development of the model, so on and so forth. So, and of course, make sure you subscribe to the channel. Check out revitfamily.biz. Thank you guys for joining me so much tonight. It was super fun, and I appreciate you guys all in the chat. And we'll talk soon. Have an awesome week, and I look forward to seeing you guys soon. Cheers.